All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving this question. This is continuation of our video on capacitor. All right, they say that a capacitor of C1, okay, our 4 points, they gave us C1 parameter. Our C1 is equal to 4.5 mu farad, which is what? 4.5 times 10 raised to power minus 6 farad, all right, is charged to a potential difference. They gave us the potential difference as what? 120 volts. Okay. And I say if the charger, that's the battery, is being removed now and then connected to and then and the charged capacitor is connected to an uncharged capacitor of 6 mu farad. Then I say calculate the potential difference. Calculate the final potential across the circuit. The final potential difference across the circuit. On a normal, and then they now say that they are in parallel. Okay, that's the first one. Then the second one, they say calculate the energy stored in the original capacitor before connecting to another one. Then calculate the energy stored in the two capacitors in parallel. So these two capacitors in parallel, on a normal, the potential difference across capacitors in parallel are the same. But here, something happened. The first one was charged. Okay, first it was charged. Then before connecting to the second one. So as it's being connected to the second one, you will notice that the potential difference will reduce because the second one is not charged. So what do we do now? Let's calculate the total capacitance. The total capacitance should be okay. First of all, let us calculate the charge here. Let's calculate the charge here because this one is charged, the other one is not charged. So let's calculate the charge here. The charge here, Q, let me call it Q naught, is equal to what? C1V, which is what? Because campus vibes are always charged. So I have 4.5 times 10 raised to power minus 6, then times 120. So this is the charge here, the charged one. So what do we have for the charge? If you multiply that, you have 0.00054 coulomb. Okay. Now, this is the charge on, in fact, this is the total charge here because the other one is not charged. This is the total charge here. Is it not true? But I know that total charge Q is equal to what? Q1 plus Q2. Is it not true? And then I have that my charge Q1 is what? C1V plus what? C2V. All right. And then don't forget that the potential difference across these must be the same. So if you now put this one now, I have that the charge I'm using for the whole circuit is 0.00054. Okay. Sorry. This is the total charge I'm using. So 0.00054 is equal to what? C1 plus C2. They will have the same volt. Okay. They will have the same volt. So what do I have now? Or instead of even doing this, let me get the total capacitance. I can get the total capacitance. The total capacitance, that is C, since they are in parallel, so C total will now be what? C1 plus C2, which is what? That is 4.5 plus 6. So what do I have? That is 10.5 mu farad, which is same as what? 10.5 times 10 raised to power minus 6. So then I have that my total charge here is equal to what? Q1 plus Q2. All right. So my total charge that I'm using here is 0.00054 is equal to, the charge here should be C1V1, okay, plus what? C2V2. But the potential difference I need now for all of them is the same potential difference that is across them. This one in particular is the potential difference across the first one, and it was charged first. You understand? So now, which is I have the same potential difference here. So what do you have now? Or let me call it C total V. Yes, is equal to what? C total, then V total. So what do I have now? So which is what? Now my Q total is equal to what? C total, V total. So what do I have now? So I'm looking for my V total. My V total will now be what? Q total all over what? C total. So what do you have? my Q total is the total charge there, and the only one that is charged is the first one. So this is my Q total, which is 0.00054 divided by my C total. I got it as 10.5 times 10 raised power minus 6. So if you divide that, you'll be getting 51.43 volts. 51.43 volts. Okay, that is that. So let's calculate the next one. The next question there, which is I said we should calculate the energy stored in the original one, and the energy stored is equal to what? Half CV squared. So which is what? 1/2 times. Okay, let me solve it here because I guess this is blocking my way. So energy stored is equal to 1/2 CV squared, which is what? 1/2 times my C is 4.5 times 10 raised power minus 6. Oh, so let me come down a bit. My BI is what? My E is equal to 1/2 CV square, which is what? 1/2 times 4.5 times 10 raised power minus 6, then times what? 120 squared. So what do I have? If you do that, you solve everything there, you'll be having 0.0324 joules. All right, so this is the energy stored in the initial capacitor. So now the energy stored in everything, now the energy stored in everything, that is for II, is equal to what? E again is equal to 1/2 CV squared, but this time around I'm using the C total and then the V total. All right, the C total and the V total, which is what? 1/2 times the C total gave me 10.5 times 10 raised power minus 6, then times uh, the V total. What did I get ahead? The V total, I got it as what? 51.43. So if you multiply them, you will be having 0.0139 joules. All right, 0.0139 joules. Okay, so that is that for that. The next question. All right. So they said now, if you notice that the energy stored in the total one is smaller than this one. Why? Because the first one was charged, while it is now being put to another one that is not charged. So that is what happened. So a capacitor is made of two parallel parallel circular plates separated 3 millimeter apart. They say if the radius of either plate is 15 cm, calculate the capacitance if the plates are separated with a sheet of paper, of dielectric constant 2.2. Okay, solution. First of all, we need don't forget that C capacitance is directly proportional to area and then inversely proportional to the distance, where you have your E as the constant. All right, so now, but I told that whenever a dielectric constant is given, don't forget that dielectric constant is ER. So just attach it to this, so you have that your C, let me say E naught, So your C will now be what? E R E naught, then A all over D. Okay, so I told you that before. So what do you have? If you do this, let us bring our parameters. They gave me that the radius is what's the radius? 15 cm, which is what? 15 over 100 times, okay, so 15 over 100, which is equal to what? 0.15. So area is equal to what? Pi r squared, which is what? 3.142 times 15, sorry, times 0.15 all squared. So the area will give me uh 0.07 meters squared. Okay, that is the area. And then the distance they gave me is 3 millimeter, which is what? 3 divided by 1000, which is 0.003123 in meters. So if you have gotten this now, and then don't forget that your E naught is always 8.85 times 10 raised to power minus minus 12. Yes, 8.85 times 10 raised to power minus 12. Unless maybe they gave you another thing. If not, that is what you will use. All right. So I will now have that my C is equal to what? E R E naught A all over D, which is what? My ER they gave me as 2.2 times my E naught is always 8.85 times 10 raised to power minus 12. Then times my area. My area is 0.07. Then divided by what? Divided by my distance, which is 0.003. So if you do the mathematics with your calculator, you'll be having 4.55 times 10 raised power minus 10 farad. All right. So and 10 raised power minus 10 is picofarad. Okay. Okay. They say that this is equal to 455 picofarad. So how do you get picofarad? If you move this one to the front, it's removing this here. So 8. So this is 455 times 10 raised power what? Minus 12 farad. All right. So which is what? Minus 12 is picofarad. All right. So that is that for that. So the next question. The next question said a sheet of paper 40 cm wide and 1.5 times 10 raised power minus 3 cm thick. Okay, between metal foil of the same width is used to make a 2.0 microfarad capacitor if the dielectric constant or relative permittivity of the paper is 2.5. Then I say what length of the paper is required. Okay, they're asking us length. Solution. They've given us the width. So I know that okay, they gave us that is wide. Then the width is equal to what? 40 cm. So what does it mean? 40 divided by 100, which is 0.4 meters. Okay, I know that area is equal to length times the width. So if I can get my area, I can now get the width. It's not difficult. This is a very simple question. So let me bring out all my parameters. The distance apart is is 1.5 times 10 raised power minus 3 cm, which is what? Um, which is 1.5 times 10 raised power minus 5 meter if you divide by 100, right? So then the next one they gave me is microfarad. That is the capacitance. The capacitance is 2.0 microfarad, which is what? 2.0 times 10 raised power minus 6 farad. Okay, so the next one they gave me is er they gave me is 2.5, and then I know my e naught must be equal to what? 8.85 times 10 raised power minus 12. All right, so now I know that my capacitance c is directly proportional to what? Reflection of this light. I don't know, is around this area, so let me write here. So my capacitance c is what? Directly proportional to area but inversely proportional to the distance, where I have my e naught as their constant. So I'm having put everybody there. I need the area, so my area will now be what? CD all over what? E naught. So which is what? My c is 2.0 times 10 raised power minus 6 times the distance. The distance is 1.5 times 10 raised power minus 3. Now divided by what? Divided by 2.5 times 8.85 times 10 raised power minus 12. All right. So that is my area. But I know that area is the same thing as length times width. So length times width is equal to all these things, is equal to 2. Just do this, you get an answer. If you get an answer, you now have that the length will now come down, the width will now come down. So this is what? 2.0 times 10 raised power minus 6 times 1.5 times 10 raised power minus 3 divided by 2.5 times 8.85 times 10 raised power minus 12. All right. This is I had not pressed in calculator, that's why I repeated it. So I'm looking for length. Length will now be, this one will come down, which is 2.0 times 10 raised power minus 6 times 1.5 times 10 raised to power minus 3 divided by what? 2.5 times what? 8.85 times 10 raised to power minus 12, then times the width. Okay, so which will now give us 2.0 times 10 raised to power minus 6 times 1.5 times 10 raised to power minus 3 divided by what? 2.5 times 8.85 times 10 raised to power minus 12, then times my width there. My w is 0.4. So if you do everything there, you will be getting if you do everything there, you'll be getting 33.9 meters. Okay, 33.9 meters. Very, very simple. So but most of the times here in this book, they are using our our e naught to be 8.5 times 10 raised to power minus 12. I don't know, some textbook will use this, some textbook will use 8.85, some times 10 raised to power minus 12, some textbook will even use 9.0 times 10 raised to power minus 12. So it depends on, but this one for ASU students, their textbook are always using this one, so you can be using this one as well. Okay, but if you look at that, your answer will look alike, just little approximation. Anyone you use, you get almost the same answer, but little approximation. So that is that for that. So let's solve 2 or more questions, and then we are good to go for that. Okay. Right. Okay. So the next question said, two circular plates separated separated a distance 3.4 millimeter apart by a sorry by a thick oil of permittivity relative permittivity or dielectric constant of 4.8 is used to make a capacitor. Is used to make a capacitor of capacitance. Okay, 565 picofarad. Then I say calculate the radius of the plate. Calculate the radius of the plate. Okay, so don't forget that picofarad means times 10 raised power 12. Don't forget. Okay. So now let's go. Solution. What did they give us? They gave us first of all capacitance as 565 picofarad, which is what? 565 times 10 raised to power what? Minus 12 farad. Okay, that's the first thing they gave us. So the next thing they gave us is the distance. The distance is what? 3.4 millimeter, which is what? 3.4 divided by 1000, sorry, which is 3.4 times 10 raised to power minus 3, right? In meters. So what else did they give us? They gave us our ER. Our ER as 4.8. But our E naught, let me use that 8.5 times 10 raised to power minus 12 is our E naught. So what else? Nothing else. So we are asked to calculate the radius. So before you calculate the radius, you need the area. Before you can calculate the radius, you need the area. So I still know that what? That my E is directly proportional to area, but inversely proportional to radius, where I have my ER and E naught as my constant. So if I need my area will now be what? E times D, then divided by ER, E naught. Okay, so what do I have now? You have my E. Sorry, is it E or B C? C. Capacitance, sorry, C. So my C is what? 565 times 10 raised to power minus 12 times my D is 3.4 times 10 raised to power minus 3, now divided by what? 4.8 times 8.5 times 10 raised to power minus 12. So if you do that, you'll be getting that my area is please press your own 4.522 times 10 raised to power minus 2 in meters squared. So but I know that area is equal to pi r squared. So what do I have? My r squared will now be what? Area divided by pi. So the r I'm looking for will now be the square root of area divided by pi, which is what? The square root of, what is my area? 4.522 times 10 raised to power minus 2, now divided by 3.14. So if you do that now, you can now get the area. You can now get the radius. And the radius, according to what they press here, they got 12 cm. Okay? They got 12 cm or 0.12 meters. So they first of all got 0.12 meters, which is same as 12 cm. All right? So see, it's very, very simple to calculate. So the next question, let me check my time. Okay, we still have time. The next question is all right, page 10. So the next question, that is question number 2. Question number 1C Question number 2b, picofarad. Okay. All right. So let me solve this particular one. They say calculate the charge. Okay. In fact, let me get one question from here. There's a very beautiful question I saw somewhere here. Okay. Let me solve this particular one. It said two two parallel plates capacitor of capacitance 2 mu farad and 3 mu farad are connected in parallel and the combination is connected to what? 50 volts DC direct current source. All right. They now say number 1, draw the circuit diagram of the arrangement. And find I, the charge on either plates of each capacitor. I, the potential difference across each capacitor. I, combined energy of the capacitor. Okay? The combined energy of the capacitor. So first of all, let us draw it. Drawing it, they are in parallel. So I'll have just something like this. They are just two. So I have that they are connected by 50 volts. And the first one here is 2 mu farad. The second one is 3 mu farad. You are done drawing it. So the next thing they say, we should calculate the charge on them. Now, when they are in parallel, P to P, parallel means that the potential difference across them are the same. So the potential difference across this are the same. So let me get their total capacitance. CT is equal to what? CT is equal to what? 2 plus 3, which is equal to what? 5 mu farad. All right. Then don't forget that campus vibes are always charged. C is equal to what? CV. So for Q1 is equal to C1V, which is what? My C1 is 2 times my V. 2 times 50, which will give you what? 100 mu farad, because I'm still using this mu. Or you say 100 times 10 raised power minus 6. Don't forget. So for the second charge, Q2 is equal to what? C2V, which is what? 3 times 50, which is what? 150 mu farad. All right. That is my Q1 and Q2. So the next thing they say we should calculate is what? the potential difference across them. The potential difference across them are the same. The potential difference across them are the same. Why? Because they are arranged in parallel. They are arranged in parallel. Okay. So it's the same potential difference that is across the both of them. So the next thing they say we should calculate is the energy. The energy. And what is energy? Please, the energy is equal to what? 1 over 2 CV squared, which is what? That is the C total. C total V squared. So what is my C? That is 1 over 2 times my C total is 5 times what? My V squared. That is, my V is 50. So 50 squared. So if you do everything, you're going to get 6.25 times 10 raised power minus 3 μ joule. Why did I put the μ? Because I'm just using 5, and this 5 is in μ. So that is that. All right. So let's solve one more question for the ones that are in series. Then we are done. Okay. They said that they are not in series. The same question, but I have 100 here. Okay. So let us draw. We want to solve when they are now in series. They are being connected